We'll see about the reasons for foaming and priming. Boiler water carryover is the contamination of the steam with boiler water solids. Bubbles or froth actually build up on the surface of the boiler water and pass out with the steam. This is called foaming, and it is caused by high concentration of solids in the boiler water, mainly due to total solids. Specific substances such as alkalis, oils, fats, greases, certain types of organic matter. This may be due to condensate return contamination, and suspended solids are particularly conducive to foaming. Priming is the carryover of varying amount of droplets of water in the steam, foam and mist mainly, which lowers the energy efficiency of the steam and leads to the deposit of salt crystals on the superheaters and in the turbines. Priming may be caused by excessive ratings or sudden fluctuation in steam demand. Priming is sometimes aggravated by impurities, mainly traces of total solids as calcium and magnesium salt in the boiler water. Some mechanical entrainment of minute drops of boiler water in the steam always occurs. When this boiler water carryover is excessive, steam carried solids produce turbine blade deposits. The accumulation have a composition similar to that of the acetyl solids in the boiler water. Priming is common cause of high levels of boiler water carryover. The condition often lead to superheater tube failures as well. These properties are governed by alkalinity, the presence of certain organic substances, and by total salinity or total cell solids. The most common measure to prevent foaming and priming is to maintain the concentration of solids in the boiler water at reasonably low levels. Avoiding high water levels, excessive boiler loads, and sudden load changes also will help. Very often, contaminated condensate returned to the boiler system causes carryover problems. In this case, the condensate should be temporarily wasted until the source of contamination is found eliminated. The use of chemical anti-foaming and anti-priming agents, mixtures of surface active agents that modify the surface tension of a liquid, remove foam and prevent the carryover of fine water particles in the steam. It can be very effective in preventing carryover due to high concentration of impurities in the boiler water. When water is evaporated in a boiler, dissolved solids or dissolved salts are concentrated and insoluble salts are precipitated. This may either be separated out in the form of non-othering soft sludge, which can be removed by blowdown, or they may get deposited on the sides of the boiler and on the tubes as othering scale. Accumulation of such scale and deposit formation on heating surfaces reduces the rate of heat transfer, risk of overheating, and failure of affected surfaces. So we required HP dosing, that is trisodium phosphate. Trisodium phosphate react with traces of calcium and magnesium salt, which is present in boiler water, and that calcium and magnesium will be converted to calcium phosphate and magnesium phosphate, which precipitates as sludge. That is, TSP will convert traces of calcium and magnesium salts into insoluble salts, that too in suspension, which can be removed easily by continuous blowdown from steam drum, which that place is called as salt compartment. This is the schematic diagram of steam drum internals. Normally, we will maintain steam drum level around 50 to 60%. This is the load on line, continuous load on line. This is a feed water inlet line, and there is a chemical dosing, HP dosing line. This place is called salt compartment. Here, the concentration of the TDS will be more by purging minimum amount of water continuously, which is called continuous blowdown. We can maintain the TDS in boiler water. So the TDS which cannot be evaporated with the steam will be maintained by the addition of HP dosing in steam drum. The continuous blowdown depends on the cycle of condensation. Cycle of condensation normally maintained in high pressure boiler between 100 to 150. It is defined as boiler water TDS divided by feed water TDS or boiler water chlorides divided by feed water chlorides. The blowdown can range from less than 1% when an extremely high quality feed water is available. That is, if you use polished water for high pressure boiler, then the blowdown rate will be less than 1%. It also depends on the cycle of condensation maintained in the boiler. If the cycle of condensation is around 150, the CBD percentage will be less compared to cycle of condensation at 100. Correspondingly, the makeup water quantity and chemical addition also will come down in high COC. That is, COC at 150, makeup addition and chemical addition will be reduced. In another important value to be monitored in steam used in turbine is silica. Silica value will be well below specified quantity in boiled feed water and in CBD. But you may find deposits of silica in turbine blades and high quantity in superheated steam only in laboratory result. This is due to colloidal silica, which is reactive at high pressure and high temperature only. This colloidal silica cannot be removed in water treatment plant by mixed bed units. It should be removed by pre-treatment only. That too by increasing alum dosing in pre-treatment of raw water. Another important method used in boiler, that is preservation during shutdown. Necessity of boiler preservation. And boiler is kept standby for a long period. It is very necessary to keep boiler in preservation to avoid internal corrosion of tube. If water is left in boiler without properly treating for oxygen removal, it can lead to corrosion. The attacks on metals take place due to improper pH level too. Corrosion of steam water circuit at ambient temperature is the result of oxidation of metal by combined effect of water, oxygen, and lowering of pH from absorption of CO2 and SO4. Types of preservation is there are generally two types of preservation done. One is dry preservation, another is wet preservation under hydraulic pressure. First method is dry preservation. The dry preservation method is effective provided the boiler is completely drainable. If superheater economizer sections are completely drainable, then this method can be practicable. The plant which will remain unopened during outage or during shutdown can be completely filled with nitrogen gas and a little overpressure is maintained to prevent oxygen ingress. The problem with nitrogen preservation is that if there is any leakage, then that has to be repaired. Nitrogen being odorless, colorless, and chemically inactive gas, it's very difficult to detect nitrogen leakage. So normally wet preservation is preferred over dry preservation. Wet preservation is preservation the boiler is completely filled with DM water containing 200 ppm of hydrogen ammonia, and hydrogen ammonia is added to raise the pH to 10. Chloride should be less than 2 ppm. So keep proper pre-mixing of chemicals with the water to ensure a uniform mixture of entering the boiler. It is necessary to backfill the boiler from superator section and ensure the water overflows from superator to the steam drum. The water should be filled from the lowest point to ensure the air is properly released from boiler. The boiler pressure should be maintained around 5 kg per centimeter squared. That is above atmospheric pressure to prevent ingress of air. Every day pressure should be monitored, it should be maintained. Sample may be collected and checked periodically for hydrogen and ammonia concentration, and if needed, chemicals to be added regularly. Hope you might have understand about the foaming, framing, the cost of foaming and priming, and chemical use to avoid foaming and priming, the HP dosing usage, how titration phosphate is used, what is salt compartment, and cycle of concentration, and where blowdown is taken, and preservation method, food preservation chemical, etc. In the coming episode, I'll be discussing about the important terminologies used in process plant and the latest technology in the industries. Do not forget to subscribe and share. Put your like and comments in the comment box. See you in the next episode. Thank you very much.